Hello, my name is Ben Zuniga, and this is my midterm progress presentation on the Europa mission for AERO4842. The scenario for this mission is to deliver a submersible to one of Jupiter's moons called Europa, and this moon is mainly made up of water and ice. The goal is to develop some sort of instrumentation that will aid this mission to conduct research on Europa, and for this project I have chosen to build a seismometer to detect the vibrations on the surface of this moon. Now, for this mission I intend to build a single-axis seismometer using Faraday's law of induction. And this law states that a magnetic flux that moves with respect to time induces a current on a coil of n turns, as seen in this equation here. I look to apply this law by having a magnet connected to a spring that will then oscillate within the coil when the frame is exposed to vibrations. And these vibrations will make the magnet move, which will induce a moving magnetic flux with respect to time, and that will create a current in the coil. As for the apparatus that I will use in this project, it includes a copper wire to make the coil, neodymium magnets, stainless steel springs to attach to the magnet, and an Arduino to digitalize the voltage signal so that these can be processed on the simulator. The approach that I'm taking to execute this seismometer consists of first doing research on these instruments to understand how they work, then make the coil to validate Faraday's law. As of this week, I have done the first 3 steps, and I'm currently working on making an amplifier using an op-amp and resistors to choose a correct gain so that the voltage signal picks up even the smallest vibrations. This amplifier will be then connected to the Arduino, which will send the data to Simulink. Then, to calibrate the system, I will use vibrations testing kit to find the relationship between the position of the magnet and the voltage induced in the copper wire. Once I have done all this, I will do signal processing, such as adding low-pass filters to get rid of the noise on Simulink. In this video, I show how Faraday's law is validated using a 75-turn coil that I made, along with a vibration testing kit that I borrowed from a course I took last year, which was Dynamics of Machinery. As you can see, the multimeter reads positive and negative voltages as the magnet moves up and down, which is ideal. Using this testing kit, I will then calibrate my seismometer as the kit provides a known input, which makes finding the relationship between voltage and frequency much easier. As for my next steps, once the amplifier is finished, I will calibrate the seismometer to then conduct signal processing and more testing. Once I'm sure that the system works, I will then develop a CAD model of the frame, which will be then 3D printed and then fully integrated to become a working seismometer. Thank you for listening.